If you haven't seen my previous video about how we see colors and what colors are, I recommend you watch it first. The video is only 2 minutes long.
Approximately 300 million people worldwide live with some form of colorblindness.
The condition is far more common in men, with about 1 in 12 men affected, compared to about 1 in 200 women.
Color vision deficiency, also known as colorblindness, is a color vision disorder where a person does not see colors the way a normal trichromat would. For example, in red-green colorblindness, the colors red and green look the same or similar. This depends on the severity of colorblindness.
There are 2 main types of colorblindness, which is not monochrome. One is anomalous trichromacy, and the other is dichromacy. Anomalous trichromacy includes protanomaly, deuteranomaly, and tritanomaly. Human dichromacy includes protanopia, deuteranopia, and tritanopia. Okay, so how do they work? What's the difference between them? Let's start with anomalous trichromacy. Here, the person has all 3 cone cells, but one of their cone's sensitivity is shifted, which means it is closer to the sensitivity of another cone, so the colors become increasingly indistinguishable. If the L cone is shifted toward the M cone, then it's protanomaly. If the M cone is shifted towards the L cone, then it's deuteranomaly, and if the S cone is shifted towards the M cone, then it's tritanomaly. Often, the person is not even aware that they have any color blindness because the shift is so small that it almost doesn't matter, and they also get normal trichromat results on color blindness tests. So there's a chance you might even have a little color blindness if you don't know about it. This is the actual vision where the person sees 2 colors as lighter or darker shades of the exact same color. Here, one type of cone of the given person is missing or does not work at all. This means that they only see 2 primary colors and a third color, which is a mixture of the 2. If the person's L cone is missing, they have protanopia, red blindness. Protans do not see red as strongly as a trichromat. For them, red is more of a darker shade. If the M cone is missing, then it's deuteranopia, green blindness. To them, shades of green and red look about the same. If the S cone is missing, then it's tritanopia. They have a harder time distinguishing between shades of green and blue, and a landscape with green grass and blue sky can appear quite monochromatic.
There is monochromacy and achromatopsia. These are all monochrome visions, and we could say they see in black and white, but that's not entirely true.
Monochromacy means that someone has only one cone cell. This can be the L, M, or S cone. For example, with S cone monochromacy, the person perceives only the wavelengths to which the S cone is sensitive. They see blues. They don't perceive red and green, so it may appear black or very dark. Cyan shades may appear grayer and darker. Blue is the brightest color for them.
While in theory, M and L cone monochromacy is possible, these types have not been definitively described in scientific literature. Achromatopsia, or rod monochromacy, is monochrome vision where all of the person's cone cells are missing or do not function at all. In this case, only the rod cells, which are also responsible for seeing in the dark, function. These people only see in black and white. It is also accompanied by other vision problems, such as poor visual acuity and extreme light sensitivity.
If you are interested in simulating color blindness, join our Discord server, and you will find the link in the announcement. The link to our server is in the description and in the comments section. Thanks for your attention, and goodbye.